and you talking about the population of the two cities, downtown and uptown. So make sure you refer to the previous page. So remember, the population of downtown can be modeled with this function, and then the population of uptown can be modeled with this function. So what we want to do is look at the basic function of an exponential model. F of x is equal to a times b to the x power. And if you remember from earlier, the a is your starting value or starting amount, and b is your growth rate. So in this case, it says what is the a value for each function and what does each a value mean? So if we look at the population of downtown, our a value is 20,000, and that's our starting population. And then for the a value for uptown, 6,000, that's our starting population. For B, it says, what is the B value for each function? So the B value is the growth rate, or the ratio is what we've been calling it in previous examples. So what is it in this case? So for downtown, the B value is actually everything that's in parentheses, so 1 minus 0.015. And then for uptown, the B value is 1 plus 0.018. That's your B value. So you can actually subtract and get a B value of, if you were to do 1 minus 0.015, you could change it to 0.985. And then for uptown, if you were to do the addition, you could change your B value to 1.018. And if you look down at the bottom of this page, I just want you to read what it says here. So an exponential growth function has a B value greater than 1. And it has the form y equals a plus times 1 plus r to the x power. And r is your rate of growth. The B value is 1 plus r. For an exponential decay function, it has a B value greater than 0 and less than 1. And it's in the form y equals a times 1 minus r to the x power. R is the rate of decay. The B value is 1 minus r. So let's go ahead and just read through that example a couple of times, and then you can review again how we're getting our a value and our b value for these two functions. So if I were to look at C, if I were to compare, I'm going to say that this is 0.985, and that's less than 1. And then 1.018 is greater than 1. And this just means if it's greater than 1, it's going to be growth. If it's less than 1, it's going to be decay, or it's getting smaller. All right, and then what we need to do is analyze the y-intercepts. So remember, the y-intercepts are the starting population. And if you were to look back at your graphs, for downtown, my starting population or my y-intercept is 20,000. And then for uptown, my y-intercept, or my starting population, was 6,000. So that's what we're talking about. So downtown is 20,000 and uptown is 6,000. And then if you are interpreting the meaning, it's just the starting population. So for C, to describe how you can determine the y-intercept in each function using only the formula. So if you were given the formula only, you weren't given any written information, you just had the population of downtown is equal to 20,000 and then 1.01, sorry, I'll use the right one, 0.985 to the t power, you can just look at the a value. And that would be the y-intercept. So whatever the population is, you just look at the a value. So we didn't even need to have any information given to us other than the formula. And you can get a lot of information about a population just by looking at the equation that represents it. You can get the starting population, and then you can look at the R value to determine is it growth or decay. And since this is less than 1, I know that it's decreasing, it's going to go down. If it was greater than 1, I know that it would be increasing.